10 mind-bending facts about the Milky Way galaxy. The word home means different things to different people. Some people attribute it to their residence. Home is the planet Earth, our globally shared clump of rock speeding through the dark regions of space, for those with a more UNESCO-themed attitude. We actually live in something much bigger than any of those, something so enormous it's impossible to fathom in any meaningful way, like an earthworm in a soccer field. We're only referring to the Milky Way, our own little puff of dust in the endless sandstorm of what is known about reality. We're not even talking about anything as large as the universe. Our planetary home. 10. This arm of Orion. The Milky Way is a barred spiral galaxy, or a spiral galaxy with a straight bar running across the middle. The Milky Way is one of the most prevalent forms of galaxies because around 2/3 of the galaxies in the known universe are spiral galaxies, and approximately 2/3 of the spiral galaxies are barred. Similar to wheel spokes, the arms of spirals like the Milky Way extend from the center and curve back toward the hub. One of those spokes, the Orion arm, is where our solar system is located. When compared to larger arms like the Perseus arm and the Carina-Sagittarius arm, the Orion arm was originally thought of simply a spur, a small protrusion. The Orion arm, however, may actually be a branch of the Perseus arm and not even have its beginnings in the galaxy's center, according to a recent theory. The issue is that it's challenging to properly grasp the scope of our galaxy. Similar to how you can't see California from Beverly Hills because you're so steeped in it, we are only able to observe the things that are right in front of us, and we must make assumptions about the overall shape and how we fit within it. Currently, our speck on the Orion arm is roughly 8,000 parsecs from the galaxy's center and about 550 parsecs from each of the arm's edges. We are as remote as it is possible to be. 1 parsec is approximately 30.9 trillion kilometers, 19.2 trillion miles. 9. Supermassive black hole. Our calculations indicate that the smallest supermassive black hole is around 200,000 times as big as the Sun. That's a decent size when compared to a typical, stellar mass, black hole, which has a mass of around 10 suns. But compared to the supermassive black hole at the Milky Way's heart, it is nothing. The dense region in the center of the spiral arm of our galaxy, Sagittarius A*, pronounced a star, has been the focus of astronomers' attention for the past 10 years. They have discovered a supermassive black hole with a mass of 4.1 million solar masses at the center of Sagittarius A*, concealed behind a dense cloud of dust and gas, based on the motion of those stars. Within a cubic parsec of the galaxy's center, this animation depicts the real star movements from 1997 to 2011 around the black hole. Stars fling around the supermassive black hole with amazing speed when they reach in close proximity to it. One of the stars, S0-2, is being drawn in and shot out of the black hole at a speed of 18 million kilometers, 11.2 million miles, per hour. Recently, we've also observed a gas cloud approach a black hole before being blasted apart by the hole's powerful gravitational attraction. The gas cloud spaghettifies, or stretches into very thin strands more than 160 billion kilometers, 99 billion miles, long, as bits of it get sucked in before other parts. 8. Particle geysers. The Milky Way center is home to an immense amount of activity, including a massive, matter-sucking hole of oblivion and a continuous cycle of star birth and death. A torrent of high-energy particles that spans the galaxy over 15,000 parsecs has also recently been observed flowing out of the galactic hub. That equates to more than 50% of the Milky Way's whole span. Although the particle geysers are invisible to the human eye, they may be observed across almost 2/3 of our sky when viewed using magnetic photography. What is the phenomenon's root cause? A never-ending jet that is slowly making its way towards the outer arms of the galaxy is powered by 100 million years of star production and stellar death. The geyser's overall energy is more than 1,000,000 times greater than that of a supernova, and the particles are moving at supersonic rates. And it's not arbitrary either. Astronomers are creating a model of the magnetic field that controls the entire galaxy based on the structure of the particle jets. 7. Fresh faces. So how frequently does a new star form in our galaxy? Dr. Roland Deal and a group of astronomers have been attempting to answer that query for many years. Aluminum-26, an aluminum isotope that is virtually always present in the zone where a star originates or dies, has been mapped out by researchers. They hypothesize that the Milky Way produces 7 stars annually based on the disintegration of dust pockets containing this metal. And a huge star explodes into a supernova roughly every 2 centuries. The Milky Way does not produce the most stars in the universe, yet it is a healthy galaxy nonetheless. A dying star ejects raw materials into space, including hydrogen and helium. These particles aggregate over hundreds of thousands of years to form molecular clouds, which finally get so dense that their center collapses due to gravity and produces a new star. Death is like the food chain in an ecosystem. Every star contains components that were once a part of billions of other stars. The likelihood of planets with Earth-like conditions is increased by the Milky Way's activity, which drives chemical development and creates new settings. 100 billion planets. There are roughly 100 billion stars in the Milky Way, a number that remains fairly constant despite all the births and deaths of stars. According to a recent study, at least one planet, and possibly more, floats around the universe for every star. In other words, our area of the cosmos has between 100 billion and 200 billion alien planets. The scientists who reached that conclusion focused their research on a particular class of stars called M-dwarfs. They account for about 75% of the Milky Way stars and are smaller than our Sun. They paid close attention to Kepler-32, a M-dwarf with 5 planets that is rather close by. Because they don't produce their own light, planets are harder to find than stars. A planet can only be positively identified when it passes directly between the Sun and Earth, leaving a little dark mark. The planets of Kepler-32 have a few distinct characteristics that have been seen in other exoplanets around M-dwarf stars, such as similar size and distance from the star. They used that information to transform Kepler-32 into a model for the occurrence of planets throughout the galaxy. Even though it's not exact, one researcher described it as the language of planet formation. They can read any star to determine whether or not it has planets using the Kepler model. 5 billion planets like Earth. Technically speaking, there are a lot of planets, 100 billion, but how many of them are identical to Earth? Not much, relative speaking. Numerous distinct kinds of planets exist, including gas giants, pulsar planets, brown dwarfs, and planets that spew molten metal into space. Even planets formed of rock are typically either too close to or too far from their star to support life in the manner we are accustomed to. There may be more than we previously believed in our galaxy. According to the findings of a new study, estimates range from 11 billion to 40 billion. After selecting 42,000 stars that resembled our Sun as a sample, researchers began their search for exoplanets in the legendary Goldilocks zone, so dubbed after the children's story, not too hot, not too cold, but just right. Around those stars, 603 exoplanets were found, and 10 of them met the criteria. The scientists were able to infer the existence of billions of identical planets that we have not yet officially discovered by studying data from the stars. These planets have the potential to sustain temperatures that allow for liquid water, which would promote the emergence of life. For Cannibal Galaxy. No matter how frequently stars are produced, the Milky Way cannot expand if it does not take in fresh material from somewhere else. The Milky Way is undoubtedly expanding as well. Recent discoveries imply that the Milky Way is a cannibal. It has swallowed other galaxies in the past and will likely continue to do so, at least until a larger galaxy comes along and drags us into it, even though we previously weren't sure exactly how that growth was occurring. Researchers discovered stars at the Milky Way's outer rim that were moving tangentially using data from about 7 years of pictures and the Hubble Space Telescope. They didn't move, like every other star, either toward or away from the center of the Milky Way. They just sort of drifted along sideways. The star cluster is thought to be a piece of another galaxy that the Milky Way swallowed, like leftovers after a large dinner. That collision probably happened billions of years ago, and there will probably be more in the future. We'll probably eat the Andromeda Galaxy in around 4.5 billion years if we continue on our current course. Unfortunately, none of us will be here to witness it. 3. Cosmological warping. Although the Milky Way is a spiral by definition, that isn't the most appropriate way to think about it because the galaxy has a bulge at its center, giving the appearance of a pancake with whipped cream on each side. Hydrogen gas molecules extending out from the spiral's two-dimensional plane caused the section to become twisted. Astronomers were perplexed by the warping's apparent lack of explanation for many years. The gas should, according to logic, be drawn toward the disk rather than away from it. The more they looked into it, the more mysterious it became since the molecules in the warp aren't only pulling apart, they're also vibrating at their own frequency. So what's the root of it? As far as we can determine, dark matter and the Magellanic Clouds, a pair of tiny galaxies. The combined mass of the Magellanic Clouds is only approximately 2% that of the Milky Way, which is not much to alter it. But as dark matter passes through the clouds, it sends out waves that appear to change how much gravitational force they exert on the Milky Way. This makes the pull stronger and tempts the hydrogen away from the galactic center. And things just grow stranger. The Milky Way's spiral arms wave in response to the Magellanic Cloud's presence with each of their orbital revolutions, much like a flag in the wind. 2. Dual galaxies. The Milky Way may be exceptional in many ways, but it's safe to say that it's not particularly rare. Given that spiral galaxies are among the most prevalent in the universe and that there are approximately 170 billion visible galaxies, it is not out of the question that there may be a few galaxies that are strikingly similar to our own. This was already mentioned in the previous section. What about one that resembles ours almost verbatim? Astronomers found a galaxy in 2012 that resembles the Milky Way in every way that we know how. It even has 2 tiny satellite galaxies in orbit around it that exactly match our own Magellanic Clouds. And those companion galaxies are uncommon. Just 3% of spiral galaxies have them, and they are short-lived. On the cosmic timescale, the Magellanic Clouds will likely disappear in a few billion years, a leisurely day. It is extremely improbable to locate another barred spiral galaxy with a supermassive black hole at its center and 2 satellite galaxies that are the same size as our own. The galaxy is known as NGC 1073, and because of how similar it is to our own galaxy, researchers are actually utilizing it to do research on it. NGC 1073 provides us with the top-down viewpoint we've always required to completely understand our own neighborhood because we're too deeply immersed to have any perspective on the Milky Way. 1. A 250 million year orbit. On Earth, a year is equal to the period of time it takes for the planet to complete one cycle around the Sun. In general, we return to our original position after a year. So it makes logical that the black hole at the center of the Milky Way is similarly orbited by our entire solar system. Each spin simply takes a little longer, about 250 million years. In other words, since the extinction of the dinosaurs, we have completed about a quarter of an orbit. Rarely is it mentioned in descriptions of the solar system that it also revolves through space like everything else. In actuality, our speed in relation to the Milky Way center is roughly 792,000 kilometers per hour, 483,000 miles per hour. That pace would enable you to complete a full rotation of the Earth in little under 3 minutes, to use a more concrete illustration. The galactic year, also known as the cosmic year, is the length of time it takes the Sun to complete one full rotation of the Milky Way. There have only likely been 18 galactic years in the Sun's existence. That's for now. We appreciate you for being here. View more our channel videos.